Hello, everyone. So this video, we are going to run through another example problem. It's from your book, page 152, practice exercise 4.16. This is how to determine the quantity of a solute by titration through the math of it. So the problem here, this is the same as in your book. A sample of iron ore is dissolved in acid, and the iron is converted to iron 2 plus ion. The sample is then titrated with 47.20 milliliters of 0.02240 molar MnO4 -1 solution. So that's like, what is that? Is that manganate? Yeah, manganate. Oh no, -1 would be that permanganate. Sorry. Okay. So a permanganate solution. The oxidation reduction reaction that occurs during titration is as follows. So we have the reaction here that is essentially what they're showing in this is this is sort of like the net ionic. It's showing the redox reaction, the changes in the oxidation states, okay, from the reactants to the product. So part A, how many moles of permanganate were added to the solution? So it wants to know how many moles from this. Okay, so all I'm going to do is just do like stoichiometry conversion. Okay, I'm going to start with the 47.20 milliliters. And again, some of this you can do in your head, or you can turn milliliters to liters in your head. I'm going to show it here. So okay, and I'm going to go milliliters to liters. Okay, and then remember I want moles, right? So now I'm going to use my molarity as a conversion, remembering you can swap the label moles over liters for molarity, right? So I'm going to do, okay, so it's 0.02240 moles of MnO4 -1 for 1 liter of MnO4 -1. I can put that on the bottom, but all right. So we get that, and that's what we want, moles of that. That's how many moles were added. So we just do the math. We get significant figures. We've got 4 and 4, so we need 4. So it's going to be 0.0011057 moles of MnO4 -1 is our answer for part A. All right. Part B, how many moles of Fe2 plus were in the sample? Okay, so what's happening here is, remember, the titration is where we're finding that equivalency point, right? So the amount of one thing equals the amount of the other, kind of, essentially. So the Fe2 plus in the reaction, when it's titrated with this, it's titrated until it finds the equivalency point. So what we can do is we can use this to find this. So I'm going to start with my answer here, 0.001057 moles, I'm writing on something here, moles of MnO4 negative 1. Now all I'm going to do is go from moles MnO4 negative 1 to moles of Fe2 plus. Okay, these numbers, again, if you don't remember from before, these numbers come from the coefficients in the balanced equation. So in front of the 2 plus, Fe2 plus, we have 5. Okay, in front of the MnO4 negative 1, we have nothing, which is a 1. So it looks like that. So this gives us 0.005285 moles of Fe2 plus. Okay. All right. How many grams of iron? Okay. So, all right. Essentially, so remember the difference between Fe2 plus and Fe3 plus is just changing electrons. Electrons, for what we do, essentially have no mass. It's not going to change the mass. So it doesn't really matter like what you're looking at. So it doesn't matter if you're like, well, how do we know if we're using the Fe2 plus or the 3? It doesn't matter. Or the 3 plus? It doesn't matter. It's the same. So we've got the moles of the Fe2 plus here. So all we need to do is turn that into grams. And that's the same way we always do it. It doesn't matter that it has that it's an ion. It has the same mass. So we're going to go moles of Fe2 plus to grams of Fe or Fe2 plus, doesn't really matter. That makes you feel better. Fe iron is 55.8. Okay. And we get 0.2949 grams. All right. All right. Last one, part D. If the sample has a mass of 0.8890 grams, what is the percentage of iron in this sample? All right, so to do this one, all we're doing, if this is the whole mass, right, how much of it is iron? Well, to do that, you would take the mass of the iron divided by the mass total of the whole sample, right, and then times 100, and this is going to equal percent of iron. Okay, so our mass of iron is 0.2949. Okay. And our mass of the sample, 0.8890 times 100 equals 33, okay, so significant figure, so 30 would be 4, so 33.17% iron. There you go. Alrighty, that's it for this problem.